Good morning, everybody. So this is going to be our notes for 5.2. We're going to be talking about polynomials, linear factors, and zeros. Okay, so we're going to go ahead and get started with the factor theorem. So the expression x minus a is a linear factor of a polynomial if and only if the value of a is a root or a solution of the related polynomial function. So if a is a linear factor is repeated in the factored form of a polynomial, then the zero related to that factor is a multiple zero. Okay, so here's our example. So if you guys notice, this factor of x minus 3 is squared. So what that means is that there's two factors of x minus 3. So when we write the solutions to this particular problem, the first one we would get x equals 0. Then that x minus 3 said it equals 0 solved, so we'd get x equals 3. But there's two of those. So then we would put multiplicity or mult 2. That means multiplicity of 2. So that means there's two zeros at x equals 3. And then the last one would give us x equals -1. All right, then we're going to go ahead and go down here. The y value of the function at an up to down turning point. So up to down turning point is a relative maximum. Okay, so this guy right here, this is a relative maximum. And then the y value of the function at a down to up turning point is a relative minimum. So in this case, this guy right here is a relative minimum. All right, so let's go ahead and scroll down. All right, so we're going to talk about different key concepts of these polynomial functions. So this whole crazy expression, p of x equals a n x to the nth power, then the next one is plus a n minus 1 to x to the n to the minus 1, blah, blah, blah. That's just representing a polynomial function. So it could be like 2x cubed plus 3x squared minus 4x plus 1. So again, in standard form, you'll have your highest degree, and then it'll go to your lowest degree. Okay, so this crazy looking thing is just a polynomial function. Put it in standard form, highest degree to the lowest degree. All right, so if we had x minus b is a linear factor of this polynomial. So we factor this polynomial down, and one of the factors is x minus b. So then that means b is a zero of the polynomial function. Okay, 0 meaning that it's going to go through the x-axis at that point. B is a root, or in other words, a solution of the polynomial equation. So when we set it equal to 0. And then B is a x-intercept. Of the graph y equals p of x. All right, so we're going to go ahead and factor these guys. So it says, what is the factored form? Remember, first thing we always check for is their greatest common factor. So we have x cubed minus x squared minus 12x. Please notice that we all have an x in every single one. So we're going to factor out that x. So we're going to get x squared minus x minus 12. Okay, we want to continue to factor this. Okay. So now I'm looking at just this piece, and I want to know what multiplies to give me -12 but adds to give me a -1. Hopefully you guys are all thinking -4 and +3. Double check it. So we should have, multiplying those together, I should get -4 times 3 is -12, and then adding those together, I would get -4 plus 3 gives me that -1. Yes, it works. So when it factors, don't forget that x will stay out front. So then we're going to get an x minus 4 and a x plus 3. And then this is completely factored because all three of these are linear factors. Meaning that the x value, or the x degree, is 1. X to the first power, x to the first power, x to the first power. All right, I love this next one. Star it, highlight it. Can't get it to move. There we go. Okay, love this one. This one's going to happen sometimes kind of often. So looking at this, I'm like, okay, I don't have a greatest common factor. I'm like, I don't really know how to factor something to the 4th degree. But since this goes 4 to nothing, so like I will always refer to these as a 4 to nothing. That's just me. Okay, so this goes 4 to nothing. I'm talking about the degrees, 4 to nothing. So what we can really use is we can use substitution. So this I could rewrite as x squared minus 5x squared to the first power plus 4. Okay, so now looking at this one, this is just a quadratic. Squared, first power, nothing, normal quadratic, what we normally deal with. So some of you guys will just be able to do this in your head, no problems. I'm just going to actually use substitution. So I'm just going to use u. We're going to say u is going to equal x squared. So where those x squares are, I'm just going to put a u. So I end up getting u squared minus 5u plus 4. Okay, basic quadratic. We should know how to factor this. So we're looking for something that multiplies to give me positive 4, adds to give me negative 5. So that would be negative 4, negative 1. Okay, let's go ahead and factor that. So I'm going to get u minus 4, u minus 1. Okay, at this point, we know that u is really x squared. So now we're going to substitute back. So this becomes x squared minus 4, x squared minus 1. Okay, now we have to see, can these factor more? Hopefully this is ringing a bell. This is a perfect square, this is a perfect square, this is a perfect square, this is a perfect square. Okay, so I have two difference of perfect squares. Okay, remember when these factors, we get a plus b, a minus b. So in this case, when the first one factors, I'm going to get x plus 2 and x minus 2. When the second one factors, we get x plus 1 and x minus 1. Okay, these are all linear factors now because they all have a degree of 1 on the x. So I know I can't factor this anymore, so this is completely factored. I like this one. Let's star it, let's remember it, reference it. All right, next page. Okay, we're going to go ahead and need a graphing calculator for this one, so get your graphing calculators ready, wherever they are, pause the video, whatever you got to do. Okay, so it says, we're going to find the zeros, determine the end behavior, estimate the relative min and max, use a graphing calculator to better estimate. Perfect. It already gives us the picture. The beautiful thing about this one is that this is already in factored form. So to solve it, we just take each one of these linear factors, set them equal to 0. So taking the first factor, we have x, we get x equals 0. Taking the second factor, x plus 2 equals 0. Taking the third factor, x minus 3 equals 0. Solving all of these, x equals 0 is already solved. This one's going to give me x equals negative 2. And then this one's going to give me x gives me a positive 3. Okay, remember these zeros will also be on your guys' graph as the x-intercepts. Oops. So notice, at 0 I have an x-intercept. At negative 2, x-intercept. And at 3, an x-intercept. Okay? Okay, now we're going to talk about end behavior. So we're going to determine the end behavior. So the way we like to write this is I say, as x is approaching negative infinity, as x is approaching positive infinity, what is our y's doing? Or what is f of x? Remember, f of x just means y. Okay, the first piece will always be the same. Always. Okay, so as x moves towards negative infinity, I want to know, where's your y going? As x moves towards positive infinity, where's your y going? So here we are. So x is moving towards negative infinity, so it's moving this direction. So as x is moving this direction, my y is going down. So my y would be approaching negative infinity. Okay, now we're going to talk as x approaches positive infinity. So as x moves this direction, where is my y going? So then my y is going up towards positive infinity. So again, the first two will always be the same. As x goes towards negative infinity, as x goes towards positive. The ones that I did in red, those are what are going to change every time depending on the end behavior. You have 4 different case scenarios on end behavior. They could both go up. They could both go down. They could go this way or this way. So we'll always have 4 different combinations. That's a possibility. Okay, so now we're going to go ahead, estimate that minimum and maximum. So that means we're just looking at the picture, just kind of estimating where it's at. Hopefully you guys realize which one's your min, which one's your max. This is my relative max. This is my relative min. So we're just going to go ahead, estimate. So our max. So looking at it, my x value, I'm going to go, it's a little past -1. So I'm going to go maybe like -1.2. Again, this is just an estimation. My y value looks like it's a tiny bit above 4, or it might just be on 4. So I'm just going to call it 4. Okay, now let's go ahead and do our min. Our min x value would be in between 1 and 2, but it's closer to 2, so maybe like a 1.8. Okay, and then our y value is way down here at -8, a little past -8, so maybe it's like -8.1, 0.2, I don't know. This is just an estimation, somewhere in there. All right, now I'm going to show you guys how to do this on your actual graphing calculators. So let's go ahead, grab our graphing calculator, get my cursor to work. All right, so here's my graphing calculator. I'll go ahead and make it a little bigger. Okay, so remember on our graphing calculator, let's just reset it. So you go second memory or second plus sign. That didn't work. Second, let's clear it. So I'm going second plus sign, which is memory, and then it's 7, 1, 2. It's always going to start you fresh, new page, good to go. Okay, so we're going to go up and graph this guy. So we're going to go to the y button, y equals, and then it goes x, and then parenthesis, x plus 2, close parenthesis, new parenthesis, and then we have x minus 3. Like so. And then we can hit graph. And there's our graph. All right, to calculate anything on a graph, you're going to be using these top buttons right under your screen. So on a normal calculator, this is right under your screen. All of these have to do with your graph and have to do with that y equals. Okay, so we want to calculate something on our graph. So if you guys notice above the trace button right here, there's calculate. So we're going to hit second trace. And then there's buttons that say minimum, maximum. Look at that. So we'll do our max first. Okay, so it says, are you to the left of the max? So you take your little buggy and you want to go to the left side of the max. So maybe right here, push enter. Now it asks you, are you on the right side of it? Move your little buggy to the right. Press enter. Those two lines should be around your maximum. It says, you want me to guess? Enter. Okay, and then it gives me this maximum right here. So let's go ahead and write that down. I always tell you guys to round 3 decimal places, that's just standard, unless, of course, we're talking about money. So, rounding those, our max, our max was at negative 1.12, and then 4.061. So our estimations were pretty good. And then our minimum was at 1.786 and negative 8.209. Okay, and then that's how you guys calculate a max and a min on the graphing calculator. All right, let's move down. Okay, so this is a great question. You guys will see these on lots of tests. So it says, what is the cubic function with the standard form with these zeros? So it's giving us the end result after factoring. It's giving us, these are the zeros. Now we want to take it, go backwards. Well, what was the original polynomial function that gave me those zeros? So we're ultimately moving backwards. Let's star this. You guys will see this on your test, 100%. It's common. Okay, so what we have is we have x equals negative 2, we have a x equals 3, and we have a x equals 5. So I'm just taking the 3 zeros and I'm just writing x equals, x equals, x equals. Okay, so we're working backwards. So now we want to get each one of these equal to 0. So I'm going to go ahead, add 2 on this one, subtract 3 on this one, and subtract a 5 on this one. Okay, so this is going to give me x plus 2 equals 0, x minus 3 equals 0, and x minus 5 equals 0. All right, so now that we have these are my 3 different factors. So we want to multiply these 3 factors together to get our polynomial expression. So we're going to just put them all next to each other now. So we're going to get x plus 2, x minus 3, x minus 5. Okay, to multiply these together, we're going to have to FOIL it all together. So you're going to pick 2 to multiply together first. So I'm just going to go ahead and multiply these 2, FOIL these 2 together first, and then we'll go ahead and then multiply that with the x minus 5. Okay, so foiling this together, we're going to get x times x, which is x squared. Then we're going to get x times negative 3, which is negative 3x. Then we'll get 2 times x, which is 2x. And then we'll get 2 times negative 3, which is negative 6. Okay, and then we still have this x minus 5. I feel like I'm going to run out of room here. That's okay. Okay, let's go ahead and simplify this. First one. So we're going to have x squared minus x minus 6 times this x minus 5. Okay, so now we're going to multiply these together. I'm going to multiply backwards just because to me it's easier. So I'm going to go this direction and then this. So I'm going to multiply the x minus 5 to the bigger one. All right, so we're going to get x times x squared gives me an x cubed. We're going to get x times negative x will give me a negative x squared. We'll get x times negative 6 will give me negative 6x. Now we're going to do the negative 5. Negative 5 times x squared is negative 5x squared. Then we have negative 5 times negative x is going to give me a positive 5x. And then we're going to have negative 5 times negative 6, which is going to give me a positive 30. Okay, so now we're going to combine our like terms. Combine like terms. Okay, so we have only one x cubed. So we're going to get x cubed. Then we're going to combine our x squareds. So we have negative x squared, negative 5x squared. So that's going to give me a negative 6x squared. Okay, then we have a negative 6x and a positive 5x. So that's just going to give me a negative x. And then we have our, like my different scribbles, which is 30. Okay, so my polynomial function that gave me the zeros, -2, 3, and 5, is y equals x cubed minus 6x squared minus x plus 30. So this is the polynomial function that gave me those zeros. And that's how you do a problem like so. Alright, so now we're going to go ahead and check this guy out. So it says find the zeros, sketch the graph, describe the end behavior, yada yada yada. So, and we're going to talk about multiplicity and what happens with multiplicities. So on this one, we're going to start by factoring it. X cubed minus 4x squared plus 4x. Hopefully in your guys' heads, you guys are all going, okay, I can take out an x out of that. So we're going to take out an x. So we're going to get x squared minus 4x plus 4 equals 0. Okay, hopefully you guys realize that this is a perfect square trinomial. Perfect square trinomial. Okay, so with this perfect square trinomial, we know it's going to factor to whatever this square root is, which is 2, and then it will take the sign of the middle one. So, when it factors, we have x, then we're going to get x minus 2 squared. There would be 2 of them. We can double check this because -2 times -2 gives me positive 4. -2 plus -2 gives me -4. So x minus 2 and x minus 2. So we write that as x minus 2 squared. Okay, this is important because this is going to give us a multiplicity. So, when we solve this, we're going to get, the first guy is going to give us x equals 0. The second one would give us x equals positive 2, but that's going to have that multiplicity of 2, because there's technically 2 x equals 2. So there's 2 x equals 2. Okay, so what happens with these multiplicities is that if it has a multiplicity of 2, it's going to act like a parabola. If it had a multiplicity of 3, it would act like a cubic function, and so on and so forth. Usually we don't really see over a multiplicity of 3, but just in case you do. Okay, so since that this is going to look like a parabola at this point, it's going to bounce. Okay, because it's going to take on that parabola shape. So it's going to come down, touch it, and bounce back up. So this will look like a bounce. Multiplicity of 2 is a bounce when we graph it. Okay, and then we're going to talk about our end behavior. So with end behavior is going to go off of what your leading coefficient is. Is it positive? Is it negative? Okay, so the easiest ones to think about with end behavior is we're going to either think of a linear function, which would be an odd, or we're going to think of a even function. I might have just said that wrong. Either we think of a linear function which is an odd function, okay, because it has an exponent of 1. Okay, and we know lines go like this or like this. So they have opposite end behaviors. Or if it's an even exponent, if it's an even degree, then we think of parabolas. Either both ends go up, both ends go down. Okay, so that's how we determine what our end behavior is going to look like. So maybe we should write that down. So we'll go ahead and do so we're going to say leading coefficient So we're going to look at the leading coefficient. Is it positive or negative? And then we're going to look at degree. Can't spell today. Which is going to be even or odd. Okay, so for instance, this leading coefficient, we're going to call it LC, is positive. And then this degree is odd. So degree is odd. Okay, so again, so if it is a even degree, you're going to think parabola. If it is a odd degree, you guys are going to think line. And you guys should know a positive parabola, they're both going up. A negative parabola, they're both going down. A positive line, which I'm backwards on the screen, would look like this. And then a negative line would look like that. Okay? So this leading coefficient is positive, and then the degree is odd. Okay, so I'm thinking line, and I'm thinking positive line. So my end behavior would have the same end behavior as a positive line. So going towards negative infinity, it's going down. Going towards positive infinity, it's going up. So our end behavior would go as x goes towards negative infinity, as x goes towards positive infinity, remember those always stay the same, f of x, or in other words, f of x just means y, and f of x will go. Okay, so as we move towards negative infinity, as x goes towards negative infinity, y is going down towards negative infinity. Let's do a different color. Okay, and then as x goes towards positive infinity, the line is going up towards positive infinity. So that's what my end behavior is going to look like. Okay, with all of this information, we can sketch a graph. It's not going to be perfect, but we can sketch what the graph looks like. So these zeros we're going to plot on our graph. So at x equals 0, there will be an x-intercept. X equals 2, there will be an x-intercept. Okay, this side is going to be going down, okay, because end behavior. Okay, then it's going to go up, and then it has to come back down to meet this, and this has a multiplicity of 2, so it's going to bounce right back up and then go towards infinity. So this, again, is just a light sketch of what this looks like. I don't know what this maximum right here is, just sketching. Okay, so this right here is the bounce. So it comes down, touches it, and then bounces right back up. Okay, and then I have the correct end behavior. This end is going down, this end is going up, like a positive line. Positive line. Okay, sorry, that was kind of like a lot of information in one, but hopefully that all makes sense. All right, let's go ahead and look at 6. Okay, so it says 6, the graph of y equals negative. So let's just talk about this before we even graph this. The leading coefficient is negative. Okay, negative line. Leading coefficient negative. This is an odd function. I think of a negative line for the end behavior. Okay, so it says use a graphing calculator to find the minimum and maximum. So let's go ahead, get back out our calculators. So I'm going to go back to my y equals, clear that guy out, and try a new one. Okay, so we have negative x cubed. Make sure you guys don't put minus. You must put negative right here, otherwise you're going to get it wrong. X cubed. And then we're going to get plus x squared. And then we have plus 6x. All right, so we're going to go ahead, type that in, and then we'll push, oh, I can make this a little bigger. There we go, that's better. And then we'll hit graph. Okay, so there's the graph. So again, to find the minimums and maximums, you guys are going to go to the calculate button, which is on top of the trace. So we go second trace. We're going to go ahead and do the minimum first. Okay, it says go to the left of the minimum. Okay, so now I'm on the left of the minimum, and then we go to the right of the minimum. Your minimum should be between these two lines. My minimum is between these two lines, so you press enter, and it gives me this minimum. So let's go ahead and write that down. Oops. Okay, so this minimum right here is at negative 1.12, comma, negative 4.061. Okay, now we'll go to the maximum. So back to our calculators. So now we're going to do second calculate again, or second trace. Now we want the max. Okay, so now we're to the left of the maximum. And then we'll move to the right of the maximum. Press enter, and then it gives me our maximum at 1.786 and 8.209, rounding 3 decimal places. I don't know why I keep doing that. Alright, so we're at 1.786 and 8.209. Alright, this is going to be the last one we do. So then it says, what are the relative maximum and minimums of this polynomial function? Where do these occur? Okay, so when it says the maximum is, those are your y values. So this is asking for the y value. And then it occurs when, so this is asking for our x values. Okay, but the y is your actual min or max. Alright, so back to our calculators. Okay, so we're going to go back to this, I guess that's behind my face. Go back to this y equals, clear it out. So now we have 3x cubed, 3x cubed, plus x squared, minus 5x. Okay, hit graph. There it is. Okay, and then we're going to go ahead and calculate this maximum first. So we go second calc or trace. We go down to max. Okay, are we to the left of the max? Now I am. Go to the right of your max and press enter one more time. Okay, so this is the x value of our max and this is the y value of our max. So weird it does that. So our maximum is at, our y value was 3.132, and it occurs when x is negative 0.865. Alright, now we're going to go ahead and do the min. So again, we go second trace. Now we want that minimum. Okay, are we to the left of the minimum? So right here would be on the left side of the min. Go to the right of the min. And press enter. And then it gives me this minimum at when x is 0.642. And then it gives me this y value of negative 2.004. Okay, so our minimum is at that negative 2.004 when x is 0.642. Alright, and then that's going to go ahead and conclude our notes for 5.2. Have a great day, everybody.